Welcome again to Organic Chemistry. This is Mr. Seeley again, and this time our installment we're going to be working on a lab of trying to extract lycopene from tomato paste and understand how much it is degraded. I'm going to give you just basic update of what we're going to be doing here. We've been hired by an advocacy group to determine how much the lycopene in tomato paste has been degraded by processing. We'll do this in three parts. We'll extract the pigments from the tomato paste. Then we'll separate them by column chromatography, and then we'll analyze them in a UV-vis spectrophotometer and determine the percent degradation. Part 1 I'm going to skip for just a second because there's actually a part 1A we should do first, which is pack a column following the procedure and the operations. I'll discuss this, but using Brockman grade 3 packing material, add a little sand on top to hold the column material in, clamp the column and drain it to get it ready, capping the ends. If you use the liquid method, make sure you use hexane at this point to pack your column. Then we're going to go back to doing part 1, which is we're going to actually get this, and the idea is as soon as you do part 1, you have to be ready to do the rest of the lab. So what you're going to do is use a mixture of petroleum ether, which is low boiling and nonpolar, and acetone to extract the lycopene, the beta-carotene, and the xanthophylls from the tomato paste. Use about a 4-gram sample, extract it with 3 10-milliliter portions, combining the extracts. Be careful, read the bottles, because there are several different solvents in this experiment. If you get the wrong bottle, you'll have to start over. And I know some of you had to do that in a previous lab, so be careful with that. Read the procedure. It's very complicated. You have to keep washing and pressing after you do each of the extracts in fluted filter paper. After you get all of your extracts, then you will add potassium carbonate to them to neutralize them. Then you'll use salt water to make it more ionic. Then you will dry it with magnesium sulfate, and you will concentrate it to about 0.5 milliliters by blowing on it with air. Do not heat it. If you dry it completely, you'll have to add some hexane back in to do that. Now once you've done that, part 2, what you'll do is you'll fill your column with eluent hexane and let it drain until its surface disappears in the sand layer. I would recommend while you're doing your concentrating of your liquid that you be running this hexane through the tube, and you run it down until it just disappears in the sand layer. You want all of the material to be wet in the column. Then what you'll do, right when that disappears from the sand layer, you're going to put your pigment on with an eyedropper, trying to spread it out into as thin and an even layer as you can. By the way, when you put the sand layer in it, you want it to be as horizontal as possible. That makes for a better separation. Then what you're going to do is put a little bit of eluent in to get the pigment out of the beaker. And then let it drain through until it just disappears into the sand. Just disappears. Then fill it up with hexane again to almost the top. Add the eluent as it drains to keep the pressure, and the tube will run. When the yellow band begins to leave the column, fill the column with 10% acetone and hexane instead of straight hexane. Continue to replenish as it runs, collecting that material in a beaker. We're going to throw it away, but go ahead and collect it. Then when you start to see the orange-red layer begin to leave, replace your beaker and begin collecting the red layer, because that's the lycopene. You want to get about 5 milliliters of that. If you can see the band coming out, you can throw away the beginnings of it, but you want about 5 milliliters of the red stuff. Put another beaker underneath and let everything else drain out because you don't care about the rest of it. Then you're going to go to the UV-vis spectrophotometer. You're going to take just maybe 1 drop of your material and dissolve it in about 100 milliliters of the 10% acetone and hexane. Your reference cell, which you will put into the machine, will be just the 10% acetone and hexane. That'll be your reference that you'll base it on, and then you'll run your sample in the 600 to 400 nanometer range. Once again, printer issues and things, just get your cameras out and you're going to take a picture of the peak. what you're going to be looking for is you're going to see probably 3 peaks, and you're looking for these 2 peaks, these last 2 peaks. And that's what we're going to do the math with. And there's a math calculation that you're going to have to do with that. It's not necessary you know how to do it for tomorrow night or for Thursday night, but I'll run another video that tells you how to analyze this for your percentage. I won't have that one ready this evening, but I'll get that for you. So you should see 3 peaks. You may see a 4th peak over here. These don't matter. You want these last 2. They should be up somewhere in around the 500 nanometer range of where they're going to go. So that's all we're looking for, is the height, the relative height of these 2 peaks from their baseline. And we should be able to get that information off of the computer when we do it. Now, as far as packing the column goes, there's some tips that can be followed. There's various websites, there's various videos on this. I've got some here for you. If you look at this website, you can probably see it up there, chemistryreviews.org, and tricks. You can just search in the search bar for column chromatography troubleshooting. I'll try to get you that link. But if you look at this information, it will tell you exactly how to do it on there. But the real key thing about them is in doing your packing. If you don't pack the column correctly, you leave gaps in it and it doesn't run right. So if you follow the methods in the back of the book or on here on how to do that, you shouldn't have an issue. Please make sure you read this box over here. Once you get it running, you can't stop it for very long or you'll ruin it. And that's really the issue you have with it. I mean, it's not a very difficult thing to do. It's just the packing. Really what you want to make sure that you do is, here is another session on how to pack a column. And really what you're going to have is, you're going to have, we don't have this fancy stuff for our column reservoirs. You're going to be continually adding them. We do not have a valve. We don't have valves on ours. All ours have is a little stopper that goes over the end of both ends of it. But essentially what you're going to do is, ours have a fiberglass thing down here where you don't have to pack anything in it. It will stop whatever you pour into it. So what you do is you fill this up with the material, the silica material. Be careful with it. Breathing this stuff is not the best for you, and it's a very, very, very fine powder. You dump it into there, and essentially, see, ours has the frit in it right there. Some do not have a frit, but ours has the frit, which is good. In a non-fritted column, you have to pack some. You have to put in some glass wool. We don't need it because we have the frit. There's dry packing method, and then there's the wet packing method. You may do either dry packing method or the wet packing method. Pros for the dry packing method: minimizes washing up. Cons: difficult to get a well-packed column. I recommend the wet packing method. These are dry packing methods still. The slurry method is the best method. Essentially what you do is you fill your column about 1/3 full of the solvent in a beaker, measure how much silica or alumina you need. Read that in the back of the book on how much you'll need depending upon the size of your column. I think we have 25 milliliter columns. Of course, I don't have one here with me. Measure about 1.5 times the volume of the silica. Add the silica to the solvent, and then make it into a slurry. And then what you do simply is pour the slurry in, you tap it down, and you let the extra. Of course, this one wastes solvent, but that's okay. It packs a lot better, and you're ready to go. And then once you've done that, that's what you're going to do in part 1A. And then when you come back in, put a little layer of sand on the top of it, and don't fill your column too full. Because if you fill your column too full, then you'll never be able to get any solvent in there, and you'll continually all night long be putting solvent in it. So make sure you read how much, and the more packing material you put in there, the longer it takes to run it as well. So I tried to do this in 10 minutes. I hope that's not too fast. Go look up a video on how to pack a column. I will put that on the website as well. And I'll show you the slurry method for that, and we'll see you Thursday.